Greetings everyone, this is Non-Expert here, back again with another video. Today we are going to be solving problem number 24 of our 30 LeetCode challenge, and the problem that has been given to us today is the LRU cache problem. So most of you will know that we've solved this problem before, so if you want a more elaborate explanation of what we're going to be doing today, you can find the link in the description below. And if you want to try solving this problem on your own, you can pause this video and check out the LeetCode link, which is also in the description. So let's just dive right in. So basically we need to design and implement a data structure for the least recently used cache, and it should support the following operations, which are the get and the put operations. So you can see get sort of takes in one parameter where you need to get the value of the key if the key exists inside the cache, otherwise you return a -1. And a put operation where you have the key and the value which has been passed in as your parameters, and you basically try to put that inside your cache. If the value is already present, then we sort of, we want to actually remove that previous value and put in the new value. And when the cache reaches its capacity, you should invalidate the least recently used item, basically use the least recently used algorithm before inserting a new item. Pretty straightforward. And we need to, do these operations in O1 time complexity. Cool. So you can have a look at this example over here where you're trying to instantiate an object of your LRU cache class, and you can see that 2 has been passed in, which is basically going to be passed in into your constructor, and you can see that's your capacity. So you cannot have, for at least this example, you cannot have more than 2 elements or key value pairs inside your hash map or your cache at least. So before we sort of go into more details about this thing, whenever somebody talks about O1 time complexity, your mentality should directly go towards implementing it using hash maps or dictionaries or whatever you want to call it. So you can have a look at this example. You're doing cache.put. So you have a put operation where you have 1 comma 1 and a put operation where you have 2 comma 2. Then you do a get of 1. So we have 1 and that returns 1 as well. But when you do that, what happens is, in essence, is that now 1 has been used uh, and 2 is the least recently used value. So when you try to put 3 comma 3, you cannot put 3 comma 3 because you're already at the capacity. So you need to remove the least recently used item, which is 2. So you pop that guy out. So you can see it's saying evict key 2 and you place in 3. And whenever you're trying to do a get of 2 now, it should return a -1 because it's no longer there inside our cache, and the thing just sort of moves forward from there. So cool. So again, like if you understand like what's going on, you would already gain an intuition behind how you would want to try solving this problem. One of the things is that you want to maintain the dictionary, and the other thing is that you want to maintain the order as well. In Python, there is something really cool which is called the order dictionary, and we're going to be leveraging that as well. There are multiple ways of solving this. You can also use a list if you're more using a list and a dictionary, and you can use that. But order dictionary also tries to follow similar paradigm, but it uses a doubly linked list so that popping the elements sort of take less time, and also you can fetch those values really quickly as well. So we're just going to start with our constructor. So our constructor is just passing in a capacity parameter. So let's just save that inside self. And also we need to have something called as cache. So let's just do that. And I'm just going to use the order dictionary that's there inside the collections module. Pretty straightforward. Now what we need to do is we need to have a get and a put. So let's just quickly do that. So get takes in a key. And basically what you want to do is you want to check whether the key is, the base condition is that check whether the key is inside self.cache. If it's not inside this thing, then what you want to do is you want to return -1. And otherwise what you want to do is you can sort of use the self.cache, which is the order dictionary. And inside the order dictionary, whenever you do a pop, well, that pop happens in O of 1. And whenever you insert a new item, whenever you insert a new key value pair, that gets appended to your order dictionary. So that goes at the very end. So that sort of helps us out as well. So what we can do is we can use self.cache key, basically fetch out the value that we presently have, then remove the self.cache key from our cache. And what we're doing is we're just removing the key value pair from our cache. And that's just because we don't want it where it was presently. We want to push it at the very end of our order dictionary. So a quick way of just doing that is just by removing it and then adding it again. So we can do that, and we can leverage the val that we had refused, and eventually we can just return val. So essentially what this entire operation is doing, what this block is doing, is it's removing the value removing the key that we're checking the values on, and then we remove it and then we append it again, and that's basically it. And the next operation that we want to take care of is the put operation. So let's just create that. So it's going to take in a key and it's going to take in a value. So over here, one thing that we need to make sure of is the base condition. And if we already have a stale key residing inside the cache, we need to remove it. So let's just quickly do that. We can say that, hey, if key is inside self.cache, you want to delete it from self.cache because it's stale now. It really doesn't matter. And we're going to place in the new value. So we'll do self.cache key and place in the value that has been passed in as the parameter, and that gets appended. And the only other check that we need to make is that we need to check that the capacity is not being exceeded. So we can just say, hey, if self dot let's do it like this. If length of the self dot cache is greater than self dot capacity, what that means is that we need to pop out one of the least recently used items. And we've already established that the least recently used item in our entire logic is going to be the first element inside our order dictionary. Inside of order dictionary in Python, if you didn't know, there's a function called as pop item, and you can leverage that to pop out the first or the last item. So pretty straightforward. So we'll use that and we'll say pop item, and it takes in a parameter which is whether you want to pop out the last value or the first value. If you pass in false, it's going to pop out the first value. And I guess that's basically it. So pretty straightforward. Let's just go ahead and run this. Hopefully this should run fine. And let's just go ahead and submit this, and hopefully this should get submitted as well. And awesome, you can see that's getting submitted, it's been accepted. And this is a pretty straightforward problem, to be honest with you, if you understand how dictionaries and lists and ordered dictionaries and all those things, how it work. And if you want a more elaborate explanation, again, I would sort of urge you to check out our other video where we go into the depth of all these things. But that was it for today's video. So if you have any comments or if you didn't understand something, do leave it in the comment section below. I'll try to get back to you as soon as I can. And if you did like this video, do give a like and do subscribe to our channel. We are a discussion over here and we would love to have you on board with us. And if you've already subscribed, you're awesome. We all know it, and have an awesome day. Thank you.